Hello everyone and welcome back to Singularity. Today, we're diving into a fascinating discovery that might just change the way we think about life beyond Earth. It all starts with the Mars Curiosity probe, tirelessly roving the red planet, scouring the Martian surface for clues about its ancient past. Recently, Curiosity detected complex organic molecules buried within ancient rocks. And here's the kicker. These molecules are similar to the ones we find here on Earth, deep within crude oil. Crude oil, that thick, black, viscous substance we extract from beneath the Earth's surface, is made up of long chains of hydrocarbons, the building blocks of organic chemistry. But here's where things get interesting. The prevailing theory among scientists is that crude oil on Earth originates from the remains of ancient plants, animals, and microorganisms. Over millions of years, heat and pressure transform this organic matter into oil and natural gas. This is the biotic origin theory, and it's the mainstream explanation accepted by most researchers. But there's a competing theory that deserves our attention: the abiotic origin of oil. According to this hypothesis, oil can also form from non-biological processes. It suggests that hydrocarbons could be generated deep within a planet's mantle, through purely chemical reactions involving carbon and hydrogen without any involvement of ancient life forms. Unlike the biotic theory, abiotic oil formation doesn't rely on biological decay, but rather on inorganic chemical reactions under extreme conditions. And the evidence for this theory is growing. For example, laboratory experiments have successfully created hydrocarbons from inorganic materials. By replicating the high-pressure and high-temperature conditions of Earth's mantle, scientists have demonstrated that hydrocarbons can indeed form from reactions between water, carbon dioxide, and certain minerals. But it's not just experiments. Natural processes here on Earth offer some clues too. Methane and other hydrocarbons have been detected leaking from deep-sea vents where conditions are extreme, and biological activity is minimal or non-existent. These vents are located miles beneath the ocean surface, where pressure and temperature are comparable to the depths of Earth's mantle. The presence of hydrocarbons there supports the possibility of abiotic formation. And the evidence doesn't end on Earth. Some scientists point to hydrocarbons found on asteroids and comets. These space rocks are remnants from the early solar system and never harbored life as we know it. The existence of hydrocarbons within them strongly suggests an abiotic origin. One of the most striking examples comes from Saturn's largest moon, Titan. Titan is covered in vast lakes and seas of liquid methane and ethane, with an atmosphere rich in complex organic molecules. And as far as we know, there's no biological process occurring there to produce these hydrocarbons. The most likely explanation is that they formed through non-biological chemical processes. The discovery of methane on Titan lends weight to the abiotic oil theory and suggests that other worlds, including Mars, Venus, and even Titan itself, could harbor hydrocarbons formed through inorganic means. And if oil or oil-like compounds do exist beyond Earth, it raises some pretty big questions. Could we one day find vast reservoirs of hydrocarbons on Mars, formed through geological processes rather than ancient Martian life? Or could Venus, with its harsh volcanic landscape, have deep reserves of abiotic oil generated through chemical reactions beneath its surface? And what about Titan, where liquid methane rains from the sky? Could we discover oil-like compounds waiting to be tapped beneath its frozen crust? The implications of such discoveries could be enormous. Not only would it force us to rethink the origin of hydrocarbons on Earth, but it could also open up exciting possibilities for future exploration and even resource utilization. Of course, we can't jump to conclusions. Detecting organic molecules on Mars doesn't necessarily mean we've found oil, whether biotic or abiotic. But it does broaden our understanding of what's possible. And as we continue to explore the solar system, these findings will help guide our search for signs of life, or even just the raw materials of life, in places we've never expected. What do you think? Could Titan's methane lakes, Venus's volcanic hellscape, or Mars's ancient past hold the key to understanding the true nature of hydrocarbons? Let me know your thoughts in the comments below. And if you enjoyed this video and want to see more intriguing topics like this, make sure to like, subscribe, and hit that notification bell so you never miss an upload. Until next time, stay curious and keep exploring. This is Singularity, signing off.